welcome.
So this is my advancer right there, right?
Yes.
Yeah.
I think this is plugged in, so everything's ready.
Okay. Well, I want to pick up where the hydrology session left off yesterday. But what I want to talk about are some observations we've been making of how reach scale geomorphology, specifically erosional and depositional environment, pool and riffle habitats change in response to flow regime. And so the observations that I want to talk about come from two different studies. These come from reference quality headwater streams in the Sierra Nevada. The observations come from periods of time that span a lot of hydrologic variation, wet, average, and dry conditions. And the first study comes from our Sentinel Stream Monitoring Network in the Sierra Nevada that we've been looking at to detect effects of drought and climate change. Here we contrast what was an older methodology that was used by SWAMP in the past, and that's been used by EPA programs in the past as well, and it's still used by some, including us, that's a stratified habitat sample technique that looks just at riffle habitat, and contrast this with the standard protocol that's used by SWAMP now, the reachwide benthos methodology that samples from mixed habitat types. The second study is one where we're specifically looking at contrasting riffled habitats and pool habitats in small headwater streams in the central Sierra Nevada. So the first thing I want to do is just review some of these sampling differences. So this graphic here shows you the positioning of target riffle stratified samples as opposed to what happens when you do the reachwide benthos sampling. So this simplistic schematic here is showing riffle zones with these wavy lines here. And of course your diamond target riffle sampling occurs only in those riffle zones. And then this regular spacing of right, left, center spacing is the traditional way that those reachwide benthos samples are taken. So of course what they're sampling is representative of the habitats as they occur, in proportion to which they occur in a particular reach. So it might be a sample that comes from a riffle zone, or it might be one that comes from a pool zone or transitional areas as well, in proportion to which they occur. So just with that as some background to keep in mind when contrasting some of the data that we're looking at. So first off, I want to talk about some of our observations from the Sentinel Monitoring Network. So these are streams that we selected to represent varying risks with which we expect the impacts of climate change on hydrology to be occurring. But with those varied risks of the effects of climate change, we also paired our sites with high and low levels of those predicted risks from hydrological models with varying degrees of natural resistance. So factors like aspect and the potential for sustaining stream flows from groundwater inputs, or meadow development or riparian development. So we have kind of a risk and resistance matrix that we're looking at to see whether or not different kinds of streams are being changed in the context of the effects of hydrologic change coming from climate. And the frame of time that we did this work in over the last 7 years now, actually, although I'll only be looking at 6 years worth of our data, frames a wide variation in hydrologic conditions, from wet conditions to average conditions to prolonged drought. These are located in national forests and national parks. Again, reference quality streams, first through third order in size. And so what I want to highlight is our observations of change over this period of time in the area of different habitats with hydrologic change, and then also contrast what we observed with changes in the reachwide benthos-based samples and the target riffle samples. We only have a subset of the data completed right now, but I can at least give you some idea of how these patterns have developed over time. The map that you see here is the location of these sample sites. So you can see it spans a wide geographic range of the Sierra Nevada, from high elevation sites in the southern Sierra, Sequoia, Kings Canyon National Park, up to Northern California and the Southern Cascade Sierra transition area of the McCloud River. So here now is just a profile of the different kinds of snowpack years that we've seen over the period of time that we've done our monitoring. So what you're looking at here is the snow water equivalents in the north, central, and southern Sierra Nevada top, middle, and lower panels. And the traces that you see here then represent different time frames here from average conditions in 2010 to above average conditions, very wet year in 2011. So in the upper graphic, middle graphic, and lower graphic, those are represented by, this is the red line is here 2010, so quite a bit above in the north, pretty close to average in the central and southern Sierra, and then very high flows in 2011, 150% or higher. And then we get this series of intensifying drought years from 2012 through 2015. So pretty much in each of these years you're seeing 2010 through 2015. 2015 sets the new record for the state in terms of the low snowpack conditions. So we frame a pretty wide variation in hydrologic condition, and the southern Sierra in particular being very dry. So what now I want to talk about is kind of a very simplified view here of what we observed during this sequence of drying years, from the first years of above average flows to very high flows throughout this prolonged drought period here. And so just in this schematic, what I want you to be thinking about is how the erosional depositional environments of riffles and pools are changing as a consequence of the changing flow regime. So simplistically here we're just looking at these blue highlight areas is where you've got pool habitat, and the darker brown regions are where we have riffle habitat. So we move from these extensive areas and prominence of riffle environments in early years of wet flows through to conditions where we see the channel area contracting, and there's an increasing ratio of pools to riffles through time. So you get diminishing and isolated small riffle environments, and then a predominance of pools, until finally you get to, in some cases anyway, in some of the streams in the data set, by the way, 24 total streams in 12 watersheds, a nested tributary in each of these 12 watersheds, again, over this risk resistance gradient. And at an extreme, some of the channels in the later drought years became intermittent, dried down to intermittent pools. So that's the extreme case. Now, instead of just looking at that schematic, let's look at the real data of what these interannual differences were. So what we're looking at here is a graphic that shows the average percent of different habitat types with time, 2010 and 11, the wet years on the left to the drier years on the right. And what this is showing is the distribution of riffle habitat, pool habitat, transitional areas, and again, in some cases, spatially intermittent streams, dry sections of stream developing as things go on. So what you see here is that there's a change from those average and wet years of conditions where you have about a 3-to-1 ratio of riffle to pools, to the later conditions where we now have about a 2-to-1 ratio of riffles to pools. So we're seeing as the drought goes on and the channel is contracting and the hydrologic environment is changing, so too is the distribution of erosional and depositional environments. I should also note that this is occurring seasonally in many cases too, especially in dry years where you have a large change from spring runoff as you go into fall. So you can get this not only interannually, but interseasonally as well. So that just frames then the physical environment as it's changing over this sequence of years. And now we want to ask the question with our data looking at reach-wide benthos samples and target riffle samples, do those reach-wide benthos samples in Sentinel streams differ more in community structure from the target riffle samples as flows recede during the drought? So you can see in this graphic here that in the wet years, the 2010-2011 years, there's not very much difference between the reach-wide benthos samples and the target riffle samples. And what we're looking at here is overall community structure in an NMS ordination. So rather than showing you the NMS ordination plot, I'm just showing you what the mean differences are between the distribution of points in a community similarity matrix. So if these two, if the reachwide and targeted riffle signal was changing in parallel, we shouldn't see any difference between what we saw in the wet years of 2010 and 11 to what we saw in the drought. But what we do see is that there's really a big difference. There's a big divergence between the reachwide benthos samples in the drought period than we see during that wet period. And that is in part a consequence of changing community structure attributable to the drought itself, but it's also a consequence of the fact that the distribution of these habitats are changing. That reachwide benthos sample is becoming much more represented by pool environment with time than it is riffle environment as it was during that very wet period. But oops. There we go. But we also see that there's taxon richness lost in the reachwide benthos samples compared to the target riffle during the drought period. So in 2010 and 11, you see that there's actually a slightly greater number of species present in the reachwide benthos samples than in the target riffle samples. And this makes sense because, of course, the target riffle is representing just the taxa that are present in the riffle environment, whereas the reachwide benthos sample includes both riffle habitat and those organisms that are found in pools. So you'd expect there to be typically then a greater diversity represented by that reachwide benthos sample than in a target riffle sample. But as we get into that drought period and there's more and more representation of the pool environment, we see there's actually a decrease in species richness in the reachwide benthos sample compared to the target riffle sample. So now I want to go on and talk about our specific comparisons of riffle and pool environments in this Kings River experimental watershed system that we looked at over a prolonged period of time that also included these extended droughts and wet periods. These are small streams that are part of the Forest Service's experimental studies of different kinds of forest treatment practices like control burn and experimental thinning of forest density. We looked at 12 sample sites, 12 stream sites between 2002 and 2015. These are at mid-elevations. We sampled riffles and pools separately. These again are all reference quality headwater streams, and towards the end of this period, and currently there are some of these forest practices that are beginning to be initiated in experimental studies of how it affects the overall watersheds of these stream systems. Larry Brown reported some of that yesterday. So just for context and the frame of hydrologic variation over time that we did these studies, this is discharge data from nearby Pittman Creek, USGS gauge on this site. And you can see where these red arrows are the sample times when we did our work. And they frame a period of time of wet period in 2005 and 2006, average in 2002 to 2004, and then dry period in 2013 to 2015. We're calling these wet, average, or dry based on comparison to the average hydrograph, which you see for historic flows represented by a 25-year period just prior to our studies on Pittman Creek. So defining a dry period is less than the 25th percentile of the flows in that historic range, or wet periods is greater than 75% of that historic flow period, and the average is in between those. So that frames where our observations are. And one of the first things we were interested in, looking at this system of 12 streams over these different sample periods of hydrologic variation, was how does the habitat area in these stream reaches change in response to flow? So what you see in here in this graph is on the x-axis we're looking at discharge, stream discharge, and on the y-axis what we're looking at is the difference between unit pool and riffle areas. So we're measuring the unit average area of pools and the unit average area of riffles across all these streams in relationship to the discharge measured at those streams. And so what you see here is that at very high levels of discharge, the stream reach as a whole is dominated by a larger area of riffle habitat. In the moderate range, we see quite a bit of a mix of the predominance of riffle habitats, which is below this line here, or pool habitats above that line. So a much greater variety and mix of habitat under those kinds of conditions. And then at low flows, even though the overall habitat is shrinking because of those low flows, the stream reaches, similar to what we saw in the Sentinel streams, are now becoming dominated by pool environment. So not a surprising result there, given what we've already seen in the Sentinel streams and what our expectations might be with decreasing flows. So what about how the communities then differ specifically between riffles and pools? Not really surprising. These are very different kinds of environments, erosional and depositional environments. So now if we look at this NMS ordination of all the pool and riffle sites over the full span of time, over all these hydrologic variations in hydrologic regime, 2002 to 2015, you can see that the pool and riffle communities distinctly differ in their ordination positions here. So they're inhabited by very different communities of organisms. You see the blue triangles on the left represent the pools, and the red circles on the right represent the riffles. So very different kinds of community composition represented in riffles versus pool environments. In addition, the Kings River study shows that there's also big differences in the densities of BMI taxa. So if you look at this graphic here, we're looking at density on the y-axis, and then different invertebrate groups in these bar columns. So on the left, we're looking at the total BMI densities. You can see in blue, they're higher in pools than they are in riffles. If we look at the total EPT, you can see there's many more in the riffles than there are in the pools. And then if you look at midges, the Chironomidae, many midges in the pool environments than we see in the riffle environment. So again, not a big surprise there. We know that from those of us who play around with bugs and bug data, that if you look at the listings that you'd see in something like the Merritt and Cummins, that a lot of these erosional and depositional taxa correspond to these same taxonomic groups. So not a big surprise there, but still important when we're thinking about how the predominance of pool and riffle habitats change in relationship to discharge. And so not only are we seeing these differences in community structure and in density, but we also see differences in the trait structure of these different environments. So on the upper panel here, what we're looking at is in black, the pool, and in gray, the riffle environments, with respect to the biotic index, which is, again, this sort of a composite community indicator of the tolerance of the organisms that inhabit those different environments. And below is a thermal index, derived from some studies that Lester Yuan has an EPA report. And so we're looking there at the greater that thermal index, the more warm water tolerant the taxa are. And so again, you can see whether it's the biotic index or the thermal index, that there's greater preponderance of these relatively tolerant or specifically thermal tolerant taxa inhabiting pools than riffles. So how have other bioassessment studies tried to account for some of these differences? So I went back and I was looking at some of the work that was done in some of the comparative studies that Andy Rehn and Pete Doty and Chuck Hawkins reported on back about 10 years ago. And so from the California Perennial Stream Assessment of 2000 to 2007, essentially what was done was that there was a fudge factor that was used there to adjust differences between target riffle values that had been collected in the past and reachwide benthos samples that had been collected in the past, because there was an underscoring that was observed with those reachwide benthos samples, likely due to the fact that they contained more pool taxa than the riffle taxa. So just a quote from that paper: since the O to E models developed with the the target riffle composite data have a slight tendency to underscore reachwide benthos samples, we added 0.04 to all reachwide benthos scores to correct for that bias. So again, an observation from a separate study here that it looks like reachwide benthos samples can have this important component that results from the incorporation of pool taxa into those samples. So again, from that comparative study, there was the conclusion drawn that the target riffle and the reachwide benthos data were essentially interchangeable, except that there were some sources of bias at higher elevations, large watersheds, and where streams were most disturbed. I'm not sure what exactly those might be attributed to, but I suspect it might be a result of pool versus riffle area differences in those different kinds of circumstances. Gerth and Herlihy, 2006, they also found a divergence between target riffle samples and reachwide benthos samples as the riffle area of the habitat decreased. So it's still, no doubt, okay for most assessments to be combining reachwide benthos samples and target riffle samples, but it's important to note that under some circumstances there's going to be a bias that exists if you are comparing the two, but maybe more importantly, from an overall interpretation of reachwide benthos samples, we need to also recognize that flow regime does have an effect in changing the proportion of riffle and pool environment, and so that can be both a source of bias, but it can also be something that tells us how geomorphic habitat is changing with flow regime and thereby affecting the reachwide benthos samples. So just to draw some conclusions from these observations in these two studies, we can see that riffle and pools differ significantly in community structure and trait structure and density. But we also see that as flows decline, there's an increased proportion of pools at the expense of riffles, and that's going to have an influence on the distribution of taxa coming from these different habitats that we're sampling along this regular series of sites that we sample with the reachwide benthos method. So with more pools in a reach, the reachwide benthos samples are going to contain more of those pools, and those are going to hold higher densities of midges and tolerant taxa, but fewer EPT, and that's going to be changing the structure of those communities. And we need to be thinking about how we can use that data to interpret and detect hydrologic change, but we also need to be cautious about how we then interpret degradation that may result from other kinds of stressors that are operating in the system. And then just a final conclusion that flow regime is certainly altering geomorphology and distribution of habitat types, and that's going to change the biological signal in the kind of invertebrate sampling that we're doing through swamp. Thanks. Questions? Lunchtime?
No.
Oh, right, sorry.
Yeah, I just wanted to ask, the ODE, Dave, was that was the Forest Service's ODE that preceded the CSCI, correct? Yeah.
Okay. Say it again.
That analysis of the ODE index that you showed where there's that bias between the two methods, that was the one that had the one that was developed in 2000 by the Forest Service by Chuck. Is that correct?
No,
that wasn't the new one.
That came from the swamp summary of the 2000 to 2007 data set. So that was I believe the first compiled swamp summary report. You're just going to use your mic. Okay.